what I have this diagram here of the unit circle. And as you can see, I did a little work ahead of time, just so, we don't have to waste time with some of the things that I was wasting time with last time. So let's take a look at some of the important things that are going to be necessary for you to understand to be successful, knowing how to use this unit circle and how to create the unit circle. SOHCAHTOA, you've heard that before, possibly. Your teachers would repeat SOHCAHTOA over and over again, only to get you able, to memorize the letters SOH, in hopes that you could remember that sine, by definition, the sine of an angle is the opposite side over the hypotenuse. Ka, C-A-H, ka, is what your teacher would repeat so that you could remember cosine of an angle is equal to the adjacent side over the hypotenuse. And toa is what your teacher would repeat in order for you to remember that the tangent of an angle is equal to the opposite side over the adjacent side. So these words, opposite, adjacent, opposite, those are words that we use in everyday life. Okay, those are words that we use in everyday life. So if I say, hey, I'm standing opposite on the opposite side of this table, let's say, well, hey, if I'm here, you're right there. Opposite means across from. Opposite means across from. And then the word adjacent, we use that in everyday life. If someone were sitting right here next to me, see, they're not opposite me. If they were sitting right here, you would say that that person is sitting adjacent to me. And I'm just trying to communicate to you that these words, if understood, would bring clarity to your trigonometry problem. It'll bring clarity to those things that we're going to talk about in a couple of minutes. Opposite means across from. Adjacent means next to. Keep that in mind as we look at these problems. I want someone to call in, though, 312-738-1060, with all of your questions that you have that are outside the scope of what we're talking about right now. Let's get back to it. All right, so what I'd like you to recall with working with this 30 is that for each of these angles, we're going to have to remember that I'm going to write the cosine of that angle, the sine of that angle, and the tangent of that angle. And I'm going to do that here. I'm going to write the cosine of 45, the sine of 45, and the tangent of 45. And I'm going to put that information right here. And then I'm going to do the same thing for 60, 90, 120, all the way around. And then we'll just show you the benefits of putting all of this in one nice, neat location. So the thing you have to be aware of is the cosine of 30. I've got the special triangle, the 30, 60, 90 triangle, which you would have to remember, the 30, 60, 90 triangle, because from this triangle, a lot of this information will obtain. So the cosine of 30, cosine, you recall, is the adjacent over the hypotenuse. Well, the adjacent or next to this 30 is radical 3. So the cosine of 30 is radical 3 over the hypotenuse, which is 2. All right, now the sine of 30, sine is the opposite. Sine, we talked about, is the opposite over the hypotenuse. The opposite of 30 over the hypotenuse. So the opposite of 30, or across from the 30, is 1. The hypotenuse is 2, so you end up with 1/2. And then the tangent of 30, the tangent we've talked about. Tangent means the opposite over the adjacent. Well, the tangent of the 30, the opposite of the 30 is 1. And the adjacent of the 30 is radical 3. So the tangent of 30 is 1 over radical 3. All right. I want to just share with you something that we're going to find helpful later on in this process, is the tangent of any angle is equal to the sine of that same angle divided by the cosine of that initial angle. So I'd like you to be able to see here that, and one way that we got tangent was we just looked at the triangle, looked at the 30, 60, 90 triangle, and we said that the opposite of the 30 was 1, the adjacent of the 30 was radical 3. Another way to get the tangent of 30, is to say that the tangent of 30 is equal to the sine of 30 over the cosine of 30. All right? And if you would have done that, the sine of 30, we already told you was half. So you have half divided by the cosine of 30, which is radical 3 over 2. All right? Now to evaluate that, you end up with 1/2 times the reciprocal. 1/2 divided by radical 3 over 2 is the same thing as 1/2 times 2 over radical 3. The 2's would cancel. And you get 1 over radical 3. And that's what we said initially, 1 over radical 3. That's just another way to get the tangent. That's another way to get the tangent that wasn't necessarily useful here, but you'll see how that'll be useful when we get to the sine, cosine, and tangent of the 0, 90, and so forth. All right, so let's keep going. What is the cosine, sine, and tangent of the 45? Well, to do that, you would need a 45, 45, 90 triangle. The ratios on the 45, 45, 90 triangle are 1 to 1 to radical 2. 1 to 1 to radical 2. So the cosine of 45 is the adjacent of 45 over the hypotenuse of 45. The adjacent to this 45 is 1, and the hypotenuse is radical 2. The sine of 45 is the opposite of the 45 over the hypotenuse. So that's 1 over radical 2. So it's a couple ways you can get the tangent of 45. You can get the tangent of 45 by saying opposite over adjacent. The opposite of 45, which is 1 over the adjacent of 45, which is 1, so you get 1 over 1. Another way you could have gotten the tangent of 45 is to take the sine of 45, 1 over radical 2, divided by the cosine of 45, 1 over radical 2. Anything divided by itself is always 1, so that's another way you could have gotten 1. In this show, we've always emphasized mastery level understanding. So let's keep going. We've got the cosine, sine, and tangent of 60. Now we got to go back to this 30, 60, 90 triangle. We got to go back to the 30, 60, 90 triangle. So let's do that. So 60, the cosine of 60 is the adjacent. Again, cosine is the adjacent over hypotenuse. The adjacent, or next to the 60, is 1. And the hypotenuse is 2. Cosine of 60 is half. The sine of 60, sine by definition is the opposite over hypotenuse. The sine of 60 is the opposite of 60 is radical 3. The hypotenuse here, sorry about that. That should be radical 3. The hypotenuse of 60, this triangle, is 2. And now the tangent of 60 is the opposite of the 60, which is the radical 3, over the adjacent of 60, in this case, which is 1. So that's the cosine, sine, and tangent of 60 degrees. All right. Notice how everything in this quadrant here, we'll call this the first quadrant, is positive, because that will change as we move around this circle. All right, so now let's deal with 90. Let's act like, this is a unit circle, so this unit is 1. Act like it's the coordinate system here. So that would be the point. This were the coordinate axis. If this were the y-axis, this were the x-axis, this would be the point 0, 1. Well, in this case, 0 would represent the cosine of 90. 1 would represent the sine of 90. And the tangent of 90 would be the sine of 90 divided by the cosine of 90, which would be undefined. You would get 1 divided by 0, which is undefined. The tangent of 90 is undefined. And you could also get the tangent of 90 from the tangent graph, but we won't discuss that for this show. All right, so what we have, and then since we're here in this quadrant, let's also find the cosine, sine, and tangent of 0. Again, if this were the coordinate axis here, the y-axis, the x-axis, this would be the point 1, 0. This would be the point 1, 0 on a unit circle. The tangent, and by the way, the cosine of 0 is 1. The sine of 0 is 0. The tangent of 0 would be the sine of 0 divided by the cosine of 0, which is 0. All right, so we've just completed the first quadrant.